In this problem, we compute the final speed of a particle by using the work-energy theorem. So this is a purely one-dimensional problem, and we're given a particle of mass 100 grams, and it's acted on by a force that points horizontally, so in the plus x direction, and that force acts through a displacement of 1 meter in that direction. But there's a bit of a complication because the force function is actually 3 newtons times sine squared of pi x. So it's a variable force, and that means we have to compute a work integral to find the total energy input into this particle. So to get the total work done here, we're going to integrate f of x dx. Now notice that I didn't even write a dot product in there because the dot product is trivial. The force vector points in exactly the same direction as the displacement increments, so I just get the magnitude of the force, f of x, multiplied by dx. So we just sub in our formula for this variable force. That's 3 sine squared pi x. And we're integrating as x goes from a position of 0 meters to a position of 1 meter. And I thought it might be nice to just take a look at what this function looks like. That force function starts at 0 at a position of 0, and then it peaks halfway through this interval, and then it comes back down to 0 at the end of the interval. So to proceed with this integral, we're going to have to apply a power-reducing identity to that sine squared term. It turns out the square of a sine function is 1/2 times 1 minus cosine of twice the argument. Again, it starts with a 1/2 out in front, so I'm going to go ahead and pull that out along with the 3. And now our integrand is transformed to 1 minus cosine of twice the argument, so cosine 2 pi x dx. Now we have to guess the antiderivative for each term, so I end up with a 3/2 times x minus 1 over 2 pi, that's there to take care of the chain rule, times the sine of 2 pi x, and this is all evaluated from 0 to 1. So if you're not used to flying through the chain rule backwards that quickly, all you have to do is just at least mentally check that this is working. When I take the derivative of this second term, I take the derivative of sine with respect to its argument, and I get cosine 2 pi x, but then the chain rule tacks on a factor of 2 pi. That's why the antiderivative has a 1 over 2 pi out in front. So when I look at this second term and I think about subbing in my upper and lower limits, when I sub in the upper limit, I get a sine of 2 pi, but that's just 0. Then I sub in the lower limit and I get the sine of 0, and that's also 0. So it actually turns out that sine term is irrelevant. All we have to do is sub in the upper and lower limits to this x. And when I sub in the upper limit, I get a 1. Lower limit gives me 0. So we just get a 1 out of that. And our final work turns out to be 3/2, or 1.5 joules. So now we know how much energy we put into this particle, and it's time to find the final speed by using the work-energy theorem. So the work-energy theorem says the amount of work we put in is equal to the change in kinetic energy. I'm just going to use a capital K for that. And the change in kinetic energy is the final minus initial. Here's where we use the fact that the initial speed was 0. In other words, it started from rest. And I can write down that final kinetic energy as a 1/2 mv final squared. So just to solve things symbolically before we plug our numbers in, I want to solve for v final here. So I multiply both sides by 2, I divide by m, and then I square root the result. And we arrive at v final equals the square root of twice the work over the mass. Now we just have to sub in our numbers. I'll just write the work as 1.5. And we have to be careful about that mass because it was given to us in grams. We need that in kilograms. So that's 0.1 kilograms. And when we run the numbers on this and round to our usual 3 significant digits, we get about 5.48 meters per second. And we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.